In this example, we're asked to set up a triple integral to determine the volume of the solid bounded by the paraboloid given by f of x comma y and the plane z equals 0. The plane z equals 0 would be the xy plane. So looking at this graphically first, here we see the graph of the paraboloid, and in yellow we have the graph of the plane z equals 0, which is the xy plane. So we want to set up a triple integral in rectangular coordinates that will give us the volume of this solid here. So going back to our work, the volume is equal to the triple integral over the region D, and notice how the integrand function here is just 1, and the region D is the solid region bounded by the paraboloid and the plane z equals 0. And differential V is equal to dz, dy, dx, or any of these 6 possible orders of integration. But for this example, we are going to use dz, dy, dx. So the volume V is going to be equal to the triple integral. And let's go ahead and put the integrand function here as 1. And then we have dz, dy, dx. So now we need to determine the limits of integration for z, y, and x. Remember, the solid region is bounded below by the plane z equals 0 and bounded above by z equals 9 minus x squared minus y squared, given by our function f of x comma y. So we know the limits of integration for z will be from 0 to 9 minus x squared minus y squared. So now we need to find the limits of integration with respect to y and z, so we'll need the xy trace to help us determine these limits of integration. To find the xy trace, we set z equal to 0 for the equation of the paraboloid. So the equation of the paraboloid is z equals 9 minus x squared minus y squared. So again, to find the xy trace, we set z equal to 0. Move the variable terms to the left, so we have x squared plus y squared equals 9, which is this circle here centered at the origin with a radius of 3. If we go back to our graph just for a moment, we can view the xy trace by looking down on the xy plane, which we see here. So now to find the limits of integration for y, we do need to solve this equation for y to determine the equation that bounds this area in the xy plane below and above. So solving this equation here for y, we'd have y squared equals 9 minus x squared. And now if we take the square root of both sides of the equation, we're going to have y equals plus or minus the square root of 9 minus x squared. So looking at the xy trace, this area in the xy plane is bounded below by the equation y equals negative square root of the quantity 9 minus x squared, and the area is bounded above by y equals positive square root 9 minus x squared. And these are the limits of integration with respect to y. So we have negative square root of 9 minus x squared to positive square root 9 minus x squared for the limits of integration with respect to y. And now with respect to x, the limits of integration will be from x equals negative 3 all the way to x equals positive 3. This is the triple integral in rectangular coordinates that would give us the volume of the solid bounded by the paraboloid given by f of x comma y and z equals 0, which would be this solid here, again bounded by the paraboloid and this yellow plane. So in this video, we just set up the triple integral in rectangular coordinates. We'll actually evaluate this using cylindrical coordinates in a future video. I hope you found this helpful.